So today, what we're going to do is we're going to look at the unit circle working backwards. So in other words, as we look at this first example on our paper, what happens is, first of all, it's already worked out for us. But what happens is we're not given the angle, we're given the coordinate of the angle, and we need to go back and identify what the angle is. Now we do have some restrictions, and by the way, the directions say list all angles theta, such that theta is in between 0 and 2 pi. And by the way, it says 0 is less than or equal to theta. So 0 can be an answer, but then it says theta is less than 2 pi. So 2 pi is not going to be an answer. So 0 to 2 pi, not including 2 pi, are types of answers. I think if you've learned that hand technique, that it's helpful in this one, because in our first case, what it says is it says cosine of theta is the square root of 3 over 2. So we know from our fingers that if we fold in our ring finger, we get 3 fingers on top, and that means the square root of 3 over 2. Well, what angle represents our ring finger? Well, the angle that represents our ring finger is pi over 6. Now the next question is, well, in this particular case, it says cosine of theta is the square root of 3 over 2. It's a positive value. What other quadrant is cosine positive in? And that goes back to our chart of the all students take calculus. Cosine is positive in the 4th quadrant, and we need a pi over 6 angle in the 4th quadrant, which happens to be the 11 pi over 6. Now that one's already done for us, and hopefully I explained it well enough for you to kind of understand what's going on. Certainly you're not going to understand everything immediately necessarily. But when we look at example number 2 here, sine of theta is still the square root of 3 over 2. Well, we know what our hand gesture is, because when we fold our index finger in, we get 3 fingers below our index finger, and that means that we've got the square root of 3 over 2. Well, what angle does our index finger represent? Well, our angle that our index finger represents is pi over 3. But what we need to look at is all of the quadrants where sine is positive. So once again, we go back to that all students take calculus, and where else sine is positive is in the 2nd quadrant. So we need our pi over 3 angle in the 2nd quadrant, which is 2 pi over 3. Tangent of theta is negative the square root of 3 over 3. One of my techniques that I use to help us remember is that 3 plus 3 is 6. So first of all, what I know is that our theta is going to be pi over 6 of some sort. But in this particular case, what we have is we have tangent of theta is negative pi over 6. But it still is going to be a pi over 6 angle. But as we take a look at our picture here, all students take calculus, we need to be in the quadrants where tangent is negative. Well, tangent's going to be positive in the 1st and the 3rd, so we need a pi over 6 angle in the 2nd quadrant, which happens to be 5 pi over 6. And we also need a pi over 6 angle in the 4th quadrant. And our pi over 6 angle in the 4th quadrant is 11 pi over 6. if we were to calculate out those values, tangent of 5 pi over 6 is negative the square root of 3 over 3. Tangent of 11 pi over 6 is negative the square root of 3 over 3. Going to go back to number 7. Number 7 says the cotangent of the square root of 3 and its positive or negative value. And the thing that may be true for you that's true for me is that I don't really know my cotangent values. But what I do know about cotangent is that it's the reciprocal of tangent. So I want to look at this from the perspective of tangent. Again, tangent is the reciprocal, so this is going to be 1 over the square root of 3 when I take the reciprocal. And I need to convert it into a format that I'm used to. So I have to rationalize here. Some of you just straight memorize this and you don't need to go through this process. But we end up with radical 3 over 3. Because square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. So ultimately what we're looking at here is that the tangent of theta is plus or minus the square root of 3 over 3. What we want to know is what angle, let's start with the first quadrant angle, has a value of the square root of 3 over 3 when we're working with tangent. And once again, 3 plus 3 is 6. So pi over 6 is going to be one of our angles. But in this particular case, we're looking at all 4 quadrants because it says positive the square root of 3 over 3, but it also says negative the square root of 3 over 3. So we need to find all of the values, so it's pi over 6. And then in the second quadrant, it would be 5 pi over 6. They're all going to be pi over 6 angles, 7 pi over 6, and then 11 pi over 6. So we really need to think about the ordered pairs, knowing a little bit about the values of tangent, and then we can apply them to our other functions. If we look at the cosecant of theta equals 2 on problem number 9, once again, I don't know much about cosecant, so what I'm going to do is I'm going to convert it into its reciprocal. The reciprocal of cosecant is going to be sine. So this is sine of theta. Since they're reciprocals, we're going to take the reciprocal of 2 and we get 1/2. And then what we want to know is, well, where? What angle of sine has a value of 1/2? Well, that's one of our first ones that we learned, and it is pi over 6. We're only dealing with positive this time, so we need to figure out where is sine positive on the unit circle. It's positive in the first quadrant, but it's also positive in the second quadrant. And then what we need is we need the pi over 6 angle in the second quadrant. And to finish, problem number 18. Secant of theta. Well, once again, like cosecant, I don't really have much memorized about cosecant and secant, with the exception that secant is the reciprocal of cosine of theta. And since we took the reciprocal, or we're going to deal with the reciprocal, we need to deal with the reciprocal here. It's going to be 1 over the square root of 2. Once again, you may have it memorized already, but I just rationalized. I'm going to multiply by the square root of 2, multiply by the square root of 2, you get plus or minus the square root of 2 over 2, because the square root of 4 is 2. So ultimately what we're looking at is the cosine of theta is plus or minus the square root of 2 over 2. On the last example, I forgot to use my hand gestures, but I will use them on this one. If we fold in our middle finger, we've got 2 fingers above our middle finger. So what angle is represented by our middle finger? And that angle is going to be pi over 4. In this particular problem, we want to list positive and negative angles, and not really negative angles, but we have positive 2 over 2 and we have negative square root of 2 over 2. So we want to find all 4 quadrants. So in our second quadrant, it's going to be a pi over 4 angle, but in the second quadrant, it's 3 pi over 4. Cosine of 3 pi over 4 would be negative square root of 2 over 2. Then in the third quadrant, it's going to be 5 pi over 4. Again, cosine of 5 pi over 4 would be negative the square root of 2 over 2. And then in the fourth quadrant, the cosine of 7 pi over 4 will be positive the square root of 2 over 2.